it be wintertime again. And now that we're working on plumbing in this bus with water tanks and things like that, we have yet more problems to solve with cold temperatures. I've gotten the inside of here taken care of, so the air temperature stays nice and toasty in here, no big deal. But plumbing down in the luggage bays, that's its whole own thing, and kind of what this video is about. So I didn't intentionally plan out this video to film. I'm just working through all the stuff I'm doing, and I grab the camera and film stuff as we go. So here is a little exploratory installation vlog, and the things I ran into and problems we're trying to solve for keeping my water tanks from freezing in this here bus that I'm living in. Hopefully you enjoy. Okay, so here we are in Home Assistant again. What I've been working on is building up some of these little ESP8266 boards with temperature sensors on them. These things connect via Wi-Fi and use almost no power. It's like 79 milliamps or something. I finally got these things up and running. It took a little bit of screwing around with the YAML code. I'm not going to go into any of that. I don't really do much coding at all, but I was able to finally get everything set up. So, what are we doing with this? Why does it matter? I'm in the process right now. We've got the tanks in the back of the bus here, and I've got one of them mostly filled with water. What I don't know is how much heat goes through this floor and down into the luggage bays. So I've made up some of these little temperature sensors that use low power. So I'm just going to stick this whole mess with a battery down in that rear luggage bay where the plumbing's at and do some data logging to figure out what the temperatures actually are in there. There's a couple different ways I can use to heat the area with the plumbing. I was thinking about like a cabin heater or a bilge heater like they use for boats. That would probably be ideal. They're anywhere from like 200 to 400 watts, just an electric heater basically. But those things are expensive. And my next thought was, depending on, you know, the data that I gather here, I could just stick an aquarium heater down inside the tank. Those things are anywhere from 10 to 50 watts, and they're a lot more direct for heating, so you don't have to heat this whole space down there. But once again, I'm not sure if I'm putting the water heater in here or not. So anyways, testing is required. Okay, so there's one of our tanks. That's going to be the freshwater tank there. This will be our gray water tank. And what we're going to do for right now is just set this thing down in here. I guess we'll put it, yeah, we'll just stick it on top of this tool bag here. That way we get a good measurement of our ambient air temperature in here. Now, I'm not very good at detecting temperature, but I can tell that in here seems a little bit warmer than out here. And this section of the floor in this particular luggage bay, this is the plywood from the... Apparently that light connection is bad. But this is the floor inside. So I think our heat will just transfer down through here maybe. But anyways, we got that thing set up in there. It does use Wi-Fi. I'm not 100% sure what our signal is going to be like, but now I've got the thing closed up in here, so we'll go back inside and figure that out. And actually, come to think of it, now that I got those little boards working, I'm going to get a whole bunch of those things. I haven't put my watch on yet. And put one in each of the luggage areas here. We've got the rear luggage bay where the plumbing's at. Then we have a compartment here where the power distribution and batteries are. Fuel tank is here. Back in there is some HVAC stuff. This is where our lift and inverter is, and this is purely storage up here. So I think what I'm going to do is make up several of those things and put one in each area so we can just data log everything. Starting to rain. But so we can just data log everything and just get some data, because I love me some data. Oh, and by the way, those little boards are like $2 to $4 each, and the temperature sensors are maybe 80 cents or something. And I think the rest of the day I'm going to work on organizing all of this stuff. It's getting a little cluttered in here. Uh-oh. Did we get out of range here? Oh no, it's still connected. I must have accidentally pulled some wires loose when I was putting that thing down in there, because we're not getting any data right now. It should be this line right here. All right, back to the luggage bay. Okay, let's see what's going on here. Oh, yeah. Our data line came loose. See that? It's not plugged in. All right, let's fix that. Yep, there we go. We've got our temperature readings back. It's that bottom one right there. Sweet. Okay, it's been a few days. Got some more stuff in. We've got project boxes. Got 6 more of these ESP8266 boards. And, oh, so this, I don't remember if I mentioned it. This is like a little voltage divider module for Arduinos. I'm going to use this in the green van to keep track of the battery voltage since it's just sitting there. And we got a whole pile of these little USB power supplies that accept 8 to 30 something volts to power it. Got some of these clip lead things that I'm going to cut apart and use to power everything. Oh, and hot glue. This was like $9. I thought it was a 50 pack, but apparently it's not. So anyways, yeah. Okay, and I can tell already just from the little bit of talking that I'm doing that I should shut up. I don't know what it is with the breathing stuff, but anyways, enough complaining from me. I'm gonna make some breakfast, then we're gonna start building some things. Oh, and our outside temperature sensor has stopped working for some reason. I'm saying that as sarcastically as I can. For some reason. Let's go look at it. I put this down here. And actually, let's pick this up upside down, just in case any water got in there. It rained extremely hard yesterday, and I was thinking that under the bus there it would be fine, but enough rain came splashing down that we definitely got our little DHT temperature humidity sensor wet. And I know those don't like that, but I'm hoping the battery's just dead. So anyways, let's take this inside and see if it's still good. Okay, well, our little board doesn't seem to be wet inside here, so that's good. This thing was outside the bag. The reason I did that is this generates a little bit of heat, and I didn't want it to throw off my temperature readings. But I'm sure this battery probably just died. So let's plug this in and see if it still works. See, what number is this? Right on there with Sharpie. Number 2. Hey, number 2 is online. Sweet. Okay, looks like it's actually still working here. And we're pulling our temperature data. Sweet, it survived the Ziploc bag in the rain. I have to keep pressing this button though, because this is a smart power bank and it doesn't pull enough power to keep it running. Okay, anyways, I'm going to start building some of this stuff, put it in cases, and make it a little more appropriate for outdoor use. Okay, right now I am switching away from these DHT11 temperature and humidity sensors because they just measure the circuit board temperature. Instead, we're using some of these things here, which are waterproof and are on the end of a long wire, so we don't have to worry about that. ESP Home is compiling the code right now and loading it on there. I think we're just about done. The YML coding is actually not that bad for these things. So anyways, doing some upgrades. Oh, and we've got, well, the outside's not working right now, but we've got the plumbing bay and then also the actual tank temperature, which right now they seem to be pretty close to each other. This one here is reporting a little bit high though, because it's also using one of these stupid sensors. But the one for the tank is actually in the water. So anyways, yeah, doing stuff. All right, this thing is ready for deployment. I had it sitting outside and I kind of sealed up some of the stuff, but like bugs already got in there and were like multiplying. So anyways, I'm sticking this thing outside, just sitting on the back tire of the green van. I'm just gonna dangle this somewhere under the van so the sun doesn't hit it and stuff. But I suppose I could, well, I don't want this anywhere near the bus because heat leaks out of this thing. I was noticing last night while I was sleeping, so these things, these metal bars here run down the entire length of the bus, including next to my current bed setup right here, which this is going to change. But I was noticing last night when it got down to like high 30s outside, these aluminum bars get very cold. These are directly connected to the window frames, and the heat, or yeah, I guess, well, cold is an absence of heat. So whether it's heat radiating out or cold radiating in, I think it's the prior. But anyways, these are cold. So these make a nice aluminum heat sink to bring the cold in. So interesting thought. These are just the levers that allow you to open the windows. But anyhow, data logging. These little power banks here seem to do pretty good. I guess I'll put a link for them down below. They're actually pretty terrible as far as like charging your phone. They don't quick charge or anything, but they will stay running with the, 75 to 81 milliamps that an ESP8266 draws. So that works pretty good. And they have USB-C charging, micro USB charging, that's not USB-C output, and 2 USB-A's out. So they're pretty inexpensive. I think they come in a 2-pack, and they work good for projects like this. You don't need a load resistor or anything to trick it into staying turned on. I am tuning all my sensors though to slow down the amount of computational things they're running to save battery, and also how often they fire up the Wi-Fi in there and stuff like that. So right now, I think I've been able to get about a week off of one of these batteries with this everything running full tilt in here. So I'm going to throttle it back and see what we can get. But anyhow, let's deploy this thing. By the way, it's just before 5 o'clock and it's already basically dark out here. So I'm just going to set this thing right here on top of this tire. Oh, I guess I got lights here. There we go. I'm going to set this on top of this tire and then just dangle this probe back here. This will just put it over the back of the springs or something. Oh, should probably make sure I don't put it on the exhaust because I do occasionally fire this thing up. There, I've got it kind of dangling off the e-brake cable there. And I can see those blue lights. So yeah. I'm gonna go back inside, let the temperature stabilize on that thing. And then get to tuning the firmware on it for power efficiency and all that. And yeah, stuff. Yes, it is raining. Okay, fast forward about 18 hours. We have our little bilge heater. This thing's pretty cool. Small company makes these things. I love it when it's obvious because the manual is just clearly inkjet printed and stapled together. Looks like they accidentally stapled it on the wrong side. This thing, well, compact or whatever, houses 2 ignition protected, basically space heaters. It's designed for use in the bilge or the engine bay of a boat. So it's got a whole bunch of safety interlocks built in as far as like overheating and shouldn't start fires and things like that. But this is about $300, has a super long cord on it. And I guess there's a couple different thermostats that can be adjusted. And we've got mounting plates and stuff on the bottom. So anyways, let me get this unwrapped and then look through the paperwork a little bit and see about getting this thing installed. Cord King, spelled with 2 Ks. This, my friends, is an IPX7 rated space heater. I never thought I would say those words in a sentence. I just find that absolutely hilarious. But yeah, this is going to keep our tanks down below from freezing. People use these in boats and stuff, but then they also use them in RVs and things. I believe it's a PTC style heater. It's what it looks like from the front here. And yeah, I'm going to plug this thing in. We're going to measure the wattage that it's pulling just to verify everything's correct. And yeah, get it installed. Okay, it is officially time to start cutting more holes in the floor. So here's our plumbing bay. And I'm trying to figure out the best place to put that little heater down here. I'm thinking I might kind of mount it up here. This is wood. I think I'd like to mount it to metal. The thing only gets 60 degrees higher than ambient, so it's not like it sets stuff on fire. But we do have some plastic HVAC return lines here. So I don't know, I'll have to figure it out. But regardless, we need to drill some holes to get down in here anyways. For, well, there's going to be multiples. For the plumbing, fresh water going in, drain coming back, and we need to get electricity like 110 volts and then also DC power down here. And I was just kind of trying to measure out how to, or where to place those holes. So the shower is basically right there, and this area here is where the bed is at. I do have one hole coming down here into this bay for the chassis battery charger. Once again, I keep those completely isolated from the rest of my, you know, house batteries or whatever in here. So I think what I'm going to do is basically just measure between that hole right there that runs power down here to this charger. I think I'm just going to measure over the distance I want, because the tricky thing here is we've got HVAC ducts that run down the inside of the bus. So the closest to the wall I can drill is going to be like over here somewhere, but trying to measure that's obnoxious. The ideal way to do it is to basically go from the inside out and then get as close to the wall as I want. So the depth setting will be controlled by that. And I know I have a big open area right here that's about 18 inches that won't interfere with anything. But trying to figure out where that goes in relation to everything else, I think if I just measure from that hole, I'll just measure over here to where I want it to be, and that'll get us our lateral measurement. And then the depth will already be set by the wall in there. I don't know if any of that made any sense, but I'm gonna grab the hole saw here. And I think this is going to be squarely underneath the bed. So it might be a little bit tricky to get under there with the drill. I guess I do have the Matebo stuff though. I think those drills are a little lower profile. Anyways, I'll figure it out. So for anyone that missed the previous video where I bought this set of Matebo HPT tools, these are basically Hitachi power tools that got the brand name Matebo. These are actually built in a different factory than all of the other yellow and bright green stuff. It's the Ryobi bag there. This thing will turn that giant 6-inch hole saw, no problem. It does take a little bit of screwing around, but using this attachment, I'm gonna put it on low, obviously. But this attachment is no problem at all. I don't know what it is with this drill, but this thing is a trooper. Like, seriously, being able to turn a hole saw that's that size with a cordless thing. Someone did their engineering and math homework correctly, I think. Okay, so ignore the music. I'm under the bed and I can't turn it off because it's playing on the computer. But anyways, the hole that goes down to our battery charger is right there. So all I need to do is measure 35 inches this way and then drill a hole right next to that HVAC duct, and that's gonna pop it right down into the plumbing bay. By the way, this whole bed setup is actually part of the same project for the shower and everything. These seats right here waste a lot of space. The way I have things set up right now is I've got a piece of plywood and some boards that run across and sit on this seat and that one up there. But these things cumulatively are wasting about 3 feet of linear floor space. So what's gonna happen is I'm gonna be building a wall right here. It'll probably go up at an angle. So when you come in, there'll be a wall, and then the bed area will be there. And then just on the other side of the bed area is gonna be another wall that goes up. And then in the area between there and the shower is where the kitchen sink is gonna be going. Then there'll be another wall on that side of the shower and on that side of the shower. And the idea is when I build the bed and everything up in here, it's going to be removable and have sort of a channel that goes through in the back, so it'll like flip up or something like that. And that's where I'll be able to access my plumbing and all that electrical. So all these wires and stuff and extension cords you're seeing on the floor are just temporary, but I'm going to set up like kind of an access hatch when I build this all out. And yeah, I just felt the need to say that because extension cords are not a permanent solution. I have gotten everything else in here set up now. There are no more extension cords running across the ceiling and whatnot. And you know, we've got, why is this camera so bad? Okay, there we go, that's a little better. But we've got, you know, some electrical running down here and stuff. So I'm gonna be adding some more conduit and things over on this side. But yeah, just side note for what you're seeing currently. Oh, and the ice maker is gonna go somewhere else eventually too. As well as the dishwasher. I'm gonna build that area back there by the sink to fit this thing. Because this is my workbench. And not having this thing available with this giant ugly thing just hanging out here, yeah, plus a lot of my documentation, instrumentation, a lot of my readouts and stuff for everything on the bus are right there. So anyways, And I think, yeah, we have just enough room to drill this. Reaching back there is going to be a trick, but yeah, here we go.
1,000 hours later.
Okay, that took about 1,000 years, but as you can see, there's now a hole, a drill-sized hole in the floor that is approximately 35 inches from that one. My arms are ruined now. That might be all I can do today. Actually, that's a lie. I'll find the energy to do more. It went through just fine, didn't seem to encounter anything. So, yeah, I guess now we go down below. Actually, first, we should probably extract this. Come out of there. Okay. Actually, why don't you guys look down there for me? Tell me what you see. That looks just about right, actually. Sweet. I was gonna say now we go down below and inspect the damage, but I think we're good. Where did this long hair come from? There's no women with long hair in like a 10-mile radius here. How did this end up on my floor? Okay. Time to get back in my chair. Oh, by the way, the whole drill kit, I'm laying on the floor and can't even breathe, or can't even move my hands, and I'm shilling stuff. This whole kit with like 5 tools was 99 bucks or something. And I'll put an Amazon affiliate link for it down below. I'll show you the bag once we get back outside. Oh, look, it's a chair. And look, it's me lying on the floor. Actually, while I'm down here, I wonder if the vacuum cleaner is within reach. Where did I put that thing? Oh, sweet, there it is. Okay, where's the light? Turn back on light. If I don't do this now, it'll never get done. Thank you, by the way, for sending me this vacuum cleaner. I know you just sent me an email, but I've forgotten your name again already. Yeah, it comes in handy, as you can see. Okay, a little more fast forwarding. I got the thing installed right here. Now, granted, heat rises, and it is kind of pumping into this little area here. But our intake is back here, output's up here. I'm just making excuses. I'm gonna see how much this thing cycles. It only turns on when it gets below 40 degrees. I forget what the cutoff point is for heating up, but it may result in this thing cycling a few times before it heats up everything in here. But we've got our wire, got it clamped off back there, comes across here loosely, and then over to this hole here. I've got some plugs that I use to plug up these holes that have cord pass-throughs. This hole is a little bit big, but we're going to be running a number of things in and out of here. I do also need to get 24 volts down here. I was just temporarily using that one battery charger as a power supply to run our SureFlow, but I do need to get 24 volts down in here from the accessory system to run our plumbing stuff and whatnot. By the way, I can't remember if I did an overview or not. This is a spin down filter, gets rid of large particles. This is how you fill the tank. So it goes through here, it goes through the spin down, and then there's a little drain off here so you can flush that thing. Then we've got a couple of something beach. I guess it says beach lane. Probably can't see that. A couple of filters. I think one's 500 micron, the other was 5 or something like that. Pumps through there and then dumps into this tank. I'm not running a pressurized system. These tanks are not designed for that. So any water demand inside is going to be handled by this pump. So basically, we're going to have to put some sealed vents on here to keep bugs and stuff from moving in. And also, I'm going to be getting an like a UVC sterilizing system This right here is one of our temperature sensors that I've built up, and the probe's going down into the tank, so I can keep a measurement of how warm this water actually is. But anyways, yeah, this line here is going to be our output that goes to the inside. Once I get the rest of the walls and stuff built in there, we should be good. There's a little strainer on the inlet of the SureFlow pump there. But yeah, we're pretty much like done, as it were, down here. I'm actually going to be putting in some more bracing for these tanks. I'm probably going to get some of that foam radiant barrier board and put it on this wall and maybe somewhere else in here too. And then behind me where I'm sitting, I'm going to build a wooden rack here basically, and the hot water heater is going to go right here. So all that being said, should be a good spot for this thing. And the other random thought I had is simply having a hole this size might let enough warm air draft down in here to keep this from freezing. So we've got a few different methods or things here. I am going to plug this up though, because I don't want everything drafting. That's windy. But anyways, I'm going to get some data. I got sensors everywhere. There's another one here that keeps track of the air temperature in here, and then also the tank. Then I've got outside and inside as well, so I can plot all that stuff on graphs. Okay, anyways, let's go inside and hook this up. Okay, I'm definitely done working on stuff for today. Heater is installed. Don't have a way to test it yet, but it's energized. And I'm gonna set up a notification on Home Assistant to tell me if and or when that thing fires up. So, yay. All right, on to tomorrow, because the rest of today is gonna be nothing. Welcome to that one thing they call the next day. So we need to get out the thermal camera and look underneath there at that bilge heater or engine heater or whatever that thing is called we installed down there. I don't think it turned on last night, and according to the numbers right now, it is, oh, apparently the tank temperature sensor just went dead. I haven't checked the batteries on that. The water temperature got down to like 37 degrees last night in that tank. I think the problem is, though, that I mounted the heater to the top of the luggage bay, which is essentially the bottom of this floor. And that means the heat that's radiating through from here goes right into that heater. Thus, it never sees the 40-degree cut-on point and doesn't turn on. So, thermal camera. We're gonna go down there all sneaky and quick like and rip that door open and instantly take 2 temperature measurements. One of the side of the heater and actually the floor that's in there. And then they're gonna pan down real quick and take a picture of something on the floor and see what the temperature differential is. Okay, so where the temperature sensor is sitting, oh, bird just ran into the side of the bus. About 32 degrees, that's what it was registering. And up here on our heater, whoa, are you kidding? Oh, there we go. 39, 40. It should have kicked on. That bright spot over there is the luggage door on the other side. The sun's hitting that, so we're getting a lot of heat through there. And here's our tank. As you can see, the temperature gradient there goes down on the bottom. I don't know, that thing's hovering right at 39 or 40. It should have turned on. According to the thermal camera, that heater's sitting right about its cut-on point. So let's try. Maybe the thermal sensor in it's stuck. I mean, it's definitely plugged in and has power. I mean, like I said, the only thing I can think of is that's basically the floor inside, which actually it's insulated pretty good. That thing currently says the floor is 39, 40 degrees, and it's over 70 in there right now. We're getting, I mean, that looks hot, but that's only 41 right there. This is 39. I wonder if this stupid heater's defective. They say to test it by putting it in the freezer or getting some air duster spray and holding it upside down. Maybe we'll do that. Yeah, it's showing 38 degrees right now. Let's check the back side. The thermal sensors are actually back here. Yeah, we're getting 39 to 41. So, that thing is completely sealed with no switches on it whatsoever, and it's riveted shut. That thing actually can be underwater and not short out, so it makes sense there's no external switches or knobs. But well, maybe I'm gonna have to get a can of air duster and figure that out. I mean, 38, I guess, for that water temperature is still okay, but like, I'd rather keep it at, you know, 40 at the minimum. So I don't know what's going on with that thing. I have not heard it run, so yeah, once again, I guess I'm gonna get some air duster and see if we can coax that thing into turning on. Maybe the thermal switches in that thing need to be cycled a few times before they will, what am I trying to say? Start working. Maybe they're stuck mechanically. I don't know. Quick update on the Lord Normal here. Definitely getting some dirt on his face, which stands to reason, being white and all, but yeah. All right, just to test my automation here, I've plugged in the ice maker into the same feed that little heater underneath there uses. So in theory, when I turn this on, we should get a notification. Might take a minute.
Notice, plumbing heater energized.
All right, cool. Well, that works. That's good. Okay, welcome back to the luggage bay. So I bought some air duster, and quick semi-political rant maybe. Buying this stuff triggered me. I had to show ID, and they had to scan my ID into the computer to buy this. Okay, I get that. You know, kids and stuff. But this is the state of Oregon. You can run around with any sort of hard drugs you want, and by and large, the cops are not going to bother you. The stuff is de facto legalized in this state. But I have to show ID to buy this. Anyways, slightly triggered. So, what we're gonna do, I've got this thing all hooked up back in here. I've got the power monitoring attached, and we're gonna do a couple of things. One, we're gonna make sure that thing turns on. Oh, and there's a dead hornet. Interesting. And then also, we're gonna look at the watts for the grid right here, because this thing runs, I'm pretty sure, on a PTC, or positive temperature coefficient, heating type arrangement. So while it's rated at 700 watts, the inrush current is going to be huge. So it's rated for 6 amps under operation. The paperwork said the inrush was 12 amps, which is going to be maybe 1200 watts or something. But I need to be able to check and see what kind of spike that's going to show. So anyways, but yeah, living in this bus here with a fairly limited power feed, I have to be careful, you know, about how much power I pull and stuff. Okay, plastic crinkly noises. Oh, do I need a knife for this? Why won't you open? They're locked. Hang on. All right, here we go. Let's see if we can get this thing to fire up. And I'm gonna keep an eye on our voltage meter here. So there's 2 temperature sensors back here, so we just need to spray that basically. Okay, it's pretty loud. It turned on. We spiked to 1200, okay, 1400, 1500, 1700. Oh, this is gonna blow my feed. We're at 1800 watts right now. Okay, it's slowing back down. Now this is overall for everything in the bus at the moment. So we're at 1400. I should have grabbed the thermal camera. So hopefully this isn't too loud and you can still hear me. But this thing only puts out, it only rises the air 60 degrees. So this will never be hot enough to set anything on fire, basically. So that's one of the safety features of it. I forget where we were at. I think we were at maybe 200 watts before that started. The total grid pull right now is 1353. And it should be settled down. Oh, actually, I'm doing this wrong. I should have been looking at something else here. Okay, so it's currently pulling 1,024 watts, which is a little bit higher than I anticipated. So I'm gonna have to reconfigure some of my electrical stuff in here. That's not giving me nearly enough headroom. Well, we're gonna let this run, and after it turns off, we're gonna trigger it again with this. And I'm actually gonna look at the meter itself that's connected directly to this thing. Anyways, not a lot of this makes sense, but more data is required. I may have to reconfigure some things for my electrical feed, because if the fridge is running or my wheelchair charger is plugged in and this thing kicks on, it's gonna overload my grid connection. Now, the fact that it does have two heating elements in it is one thing. I could potentially disconnect one of those. But I don't know. Okay, interesting note. So, okay, there it shut off. I think I might have been right. I think we just needed to cycle the, because they're mechanical temperature sensors, they might just need to have been cycled a couple of times. Anyways, at least we know it works now. We know how much power it pulls. So what we're gonna do here, I think right now it's only sampling power every like 40 seconds or something like that. Let's see, monitoring mode. We can up this to every 2 seconds, and that'll give us a little bit more data when we try it. Okay, anyways, whatever. I'm gonna let this thing cool down for a while so it gets stone cold again. Then we're gonna come back out here, try it again, and measure our power. And yeah, things. Okay, we've got the proper data showing here on the iPad now. Let's go ahead and trigger this thing again and see what we get. $1,500 watts, falling down to 1,300. Okay, we're down to 1,050. Okay, so it looks like this thing pulls about 1,000 watts. It did turn on easier that time, and it also didn't pull quite as much power. So I don't know. I'm thinking maybe I just need to cycle this thing a few times to get those mechanical temperature pots to function correctly. All right, well, I'm gonna keep playing around with this and I'll let you know what I find. Okay, so I have a plan. I think the only way to make that bilge heater work down there without potentially overloading my grid stuff, which it is protected. If it does overload, it will disconnect in theory without damaging anything. I think I'm gonna run a separate inverter just for that heater. I've got a Xantrex one that goes up to 1,875 watts, and it's a pure resistive load, so that's good. So it surges up to 1,800 and then settles down at about 1,000. So I think I'm gonna have to make a trip to the warehouse and get that thing. I'm trying to remember. I have seen it recently. I don't know what part of the warehouse it's in, but it is out there. It's actually the inverter that I used in the video where the power went out for like a week or something. But anyways, I think that's going to be the safest way to do this, because especially if I'm asleep and my chair is charging, got my breathing machine going, if that thing kicks on, and like say the fridge is running too, it's going to knock out the grid, which isn't necessarily a bad thing because the inverter will instantly take over without missing a beat. But with the pellet stove and everything else running, I could potentially deplete my inverter batteries overnight if that happens. So I think the safest way to do this is just going to have it to be run off the batteries with a separate inverter. That thing I don't think should cycle on for more than any amount of time, or I don't think more than 20 minutes at a time maybe. But I do have a grid battery charger, so in theory that'll offset the drain on the batteries. Yeah, living in a bus with a limited grid power feed makes things interesting at times. But yeah, I think that's going to be the solution. Yeah. So for now, I don't think I'm going to be able to get out to the warehouse today. And it's supposed to get down to 27 tonight. So I think what I might do is rearrange some of my wiring and stuff and make sure there aren't any excessive loads running when that thing kicks on. Or maybe I could set up an automation on Home Assistant. Although that's a bit risky, because I could set up Home Assistant to detect that and turn off a bunch of loads in here and potentially turn them back on. But that's relying on a lot of things to work correctly. And while technology does work and Home Assistant is reliable, there's a lot of variables there. So I think I might just run an automation tonight and have the announcement set up here with the speakers to let me know what's going on. Which would wake me up, but that's fine. Things. I'll have to ponder this. I'll let you know what I come up with. Okay, I've got a basic automation set up here. We're going to do one final test. What it's set up to do is if I'm pulling more than 1500 watts from the grid for 2 seconds, it will disconnect the grid and turn on the inverter. So what we want to look at here is right now we've got about 400 watts pulling on the entire grid, and then this is our inverter grid cutoff here. So we want to watch that number, and then that switch should automatically toggle. So I'm going to activate this heater, and let's see what our numbers jump up to and see if this actually works. There we go. Okay, 1600 watts, 1700, grid turned off. All right, I think we're good. So I think the way this heater works is there's two elements in it and they don't both turn on at the same time. So one turns on and it looks like our inrush current builds for about 3 to 4 seconds. So it's not just hitting everything constantly all at once with 1800 watts. So it ramps up a little bit, which with it not hitting all at once doesn't hammer my my grid connection quite as hard. So it ramps up, Home Assistant detects it, cuts off the grid, and now the battery charger is offsetting that load a little bit. So you can see we're probably 175 watts more than we were before, about 150 watts more. That's because that charger is now offsetting this load. So anyways, this is going to work for tonight. Currently, yeah, I've had the door open all day. The pellet stove's on now, so it's 54 inside. Outside is 34 degrees. This bay that I'm sitting in is about 48. You can see that's dropping because the door's open. And our tank temperature is, the water is currently 42.4 degrees. And that's via this sensor that's hanging down in here. So anyways, this will work for tonight. Also, when this thing turns on, it announces inside and lets me know. So at some point during the night, I'll wake up and check on things and maybe reconnect the grid or something. So we're good for now. Well, good for now until I get the inverter to install it. This is just a temporary stopgap. Okay, well, that heater is clearly doing something down there. We've got about roughly a 10-degree rise from outside. That heater is supposed to run from 40 degrees to 46 degrees. Anyways, we'll see how it goes tonight. I think it's about as good as we can do for now. It obviously takes a little bit of time for that mass of water to change in temperature. There's a very large thermal mass there. There's probably only about 40 gallons in there right now. I have it partially filled though, just kind of for testing purposes. Oh, and also because I had to disconnect my my well water hose out there. That was just laying on top of the ground. But I noticed this morning when I went out there that the hose nozzle had exploded from the little bit of water that was in it freezing overnight. So that's disconnected now. I use bottled or pre-purchased water in here for like drinking and cooking purposes anyways. So should be good with that. Always interesting though when you're setting up new systems like this and trying to figure stuff out. It's like, oh, I'll just stick that thing down there and we'll be good. Well, it got way below the set point down there last night and that thing did not come on. Like I said, I think it was just those mechanical temperature switches had to cycle a few times. We'll find out tonight for sure, but I do enjoy a project and learning stuff. It's just, it's never a straightforward task when you install something new like that. So anyways, it's a fun adventure. Yeah, we'll see what happens tonight. I found my Columbia Sportswear Omni Heat hat. This is the one with the tin foil inside of it. Anyways, I don't know what changed or something. It got down into the 20s again. Actually, it's been 2 days now. The last 2 nights, it's gotten down below 30. But the luggage bay has never gotten down to 40 degrees. So, I don't know. I'm confused. Anyways, that heater seems to be working now. I've manually turned it on with the air duster freezer spray probably 4 or 5 more times. And it almost instantly kicks on now the second I hit it with that spray. So I think it was just those mechanical temperature pots in there that are completely sealed and not adjustable. I did also notice that when I spray it, I can hear one faint click, and then very shortly after I hear a second click. So that dual redundancy in there in both of those heaters, like I said, spreads out the inrush load a little bit. But I'm pretty confident now that thing's going to work fine. It is interesting in the manual, they said they highly recommend testing it before you install it. So I'm wondering if they know that those little mechanical temperature things need to be worked a little bit before they'll kind of wear in and actually trigger correctly. Because there was a few people in the reviews that said first off, when they first installed it, the temperature got way lower than it was supposed to. But then after using it, it got better. So we're just going to go with that. It was like $287 for that thing. I will put a link for it down below, like Amazon affiliate link, just if you want to check it out. Really cool device, completely waterproof. It doesn't matter if that thing fills with water. They said they just recommend that usually bilges in boats are full of garbage and dirt and dust. They recommend keeping the water out just to keep the dirt from flowing in there. But a ton of people use those things in RVs and whatever else. So it seems like a cool product. So I did make it out to the warehouse. That inverter that I have, I neglected to remember that it is a 12-volt inverter. I'm running a 24-volt system in here, which means that 12-volt inverter is not going to work. So my plans for running that thing on its own separate inverter will involve me buying another 24-volt inverter. So I don't know when that's going to happen. Repairs and stuff on the van, that's still going to be almost $700. And I don't know, it's always something. So anyways, I guess I'll find one and put it on the wish list. I mean, it is awesome that a lot of people like to buy stuff off of there. It makes me feel a little weird though sometimes that people just spend a bunch of money. But I won't say no, I guess, if someone wants to buy something. Anyways, we're going to call that good for now. This video that was supposed to be short is, of course, 47 minutes long. I don't know what it is. 47 minutes is the magic number for all the videos I've been releasing recently. I don't understand that. I don't plan it, but it just seems to be a thing. So anyways, thanks for hanging out, and more stuff soon. All kinds of things going on as per usual. I'll see you guys later. This is such a time saver.